The question is, why does an electric bulb light up? Imagine when you flick the switch in your hand, the light spreads throughout the house. But have you ever wondered what happens behind this 0.05-second event? How does so much light come out through a thin wire? And why does 90% of your bill go to waste in this process? Let's explain it step by step. Step 1. It starts with the race of electrons. When you switch on, very small particles called electrons start running through the electrical wire coming from the wall of your house. Energy is hidden in the movement of these electrons. The entrance to these electrons inside the bulb is the filament. It is a very thin, twisted wire, so thin that it is difficult to see with the naked eye. Let's say this filament is about 1 meter long, but it is twisted so tightly that it looks like only 1 to 2 centimeters. As the electrons rush through this narrow path at high speed, the crowd becomes so large that they start colliding with the atoms in the filament. Step 2. Heat is generated from the collision. With each collision, the kinetic energy of the electrons is transferred to the tungsten atoms. As a result of this collision, the atoms start to oscillate, and that is heat. The filament acts as a resistor. The resistance is the obstacle that the filament creates to push this huge crowd of electrons. How much heat will be generated depends on how strong this resistance is. Let's say your bulb is 100 watts. This means that it consumes 100 joules of electrical energy per second. All of this 100 joules of energy are converted into heat in the filament due to the resistance. In this heat, the temperature of the filament rises to about 2,500 degrees Celsius. Step 3. The language of hot objects, how heat becomes light. Now let's come to the main question. How does light come from this heat? A fundamental truth of physics is that every object above absolute zero, minus 273.15 degrees Celsius, emits radiation. As the temperature of an object increases, the wavelength of the radiation it emits becomes shorter. When the filament is at room temperature, it mainly emits infrared, invisible radiation. But when its temperature exceeds 500 degrees Celsius, it begins to emit visible light. And when it reaches 2,500 degrees Celsius, a part of its radiation is detected by our eyes. This process is called luminescence. Step 4. Why tungsten? Everything I have said so far can be done with any metal. So why is the filament tungsten? Because the melting point of tungsten is 3,422 degrees Celsius. The filament has to be heated to 2,500 degrees Celsius. No other metal can withstand this much heat. It will melt. Tungsten survives safely at this temperature too. Now, another important calculation. Our eyes can only see visible light. Even when the filament reaches 2,500 degrees Celsius, only 10% of its total radiation is visible light. The remaining 90% is infrared or thermal radiation, which we cannot see. We only feel. Step 5. So what happens to the total energy? Here comes the math of the bulb's efficiency. Let's say the bulb draws 100 watts of power. However, of these 100 watts, 80 watts are converted into thermal radiation, and only 12% of that 80 watts, or about 9.6 watts, is visible light. That is, even if you consume 100 watts of energy, you only get a little more than 10% of the light. The remaining 90% of the energy is spent heating the house. In comparison, an LED bulb gives out 70 to 100 lumens of light per watt, which is 5 to 6 times more efficient than an incandescent bulb. This is why these old bulbs are being discarded in many countries. Why does the whole thing happen so quickly? You may be wondering, why does the light come on as soon as you press the switch? This is because the filament is so thin that its mass is very low. It takes very little energy to heat an object of low mass. The whole process is completed in just 0.05 seconds, and you get light. If you like the video, like and subscribe to stay with us.